If you walk into any high-end audio showroom, you will immediately notice the massive copper cables connecting the equipment. There is a very deeply held belief within the audio world that maximizing the thickness of these wires is the ultimate path to achieving perfect sound quality. Engineers originally bulked up these cables to solve a single and very straightforward mathematical problem, which was simply reducing the amount of electrical resistance. But by focusing too much on just how big something was, they completely overlooked a physical force that was much more damaging. When you send a very sensitive audio signal into a large, multi-stranded cable, you essentially compel that signal to find its way through a complex maze. The waveform itself splinters out across hundreds of overlapping copper strands, creating chaotic, unpredictable, crisscrossing current paths. These erratic paths then generate very strong, powerful, competing electromagnetic fields inside the cable, causing significant interference. While the signal moves along its path, these internal magnetic fields are constantly inducing a voltage in the neighboring strands, which ends up scrambling the exact timing of all of the electrical impulses. You can hear this timing error quite distinctly within the room. A smeared electrical signal directly translates into a spongy, bloated bass response, and also a harsh, artificial emphasis on the higher frequencies. Prioritizing sheer mass will actively destroy the temporal accuracy of the music itself. The thickest wire you find in the room is often the one doing the most damage to the overall performance quality. To ensure the integrity of the signal, it's crucial to reduce the mass and strictly isolate the conductors. This particular design is the architecture of a single solid core flat cable. By keeping two perfectly parallel thin solid wires at a constant mathematically precise distance from each other, we can tightly control the electromagnetic field. Because these wires will never twist or even touch, mutual induction effectively drops to almost zero. The audio waveform then travels very smoothly, ensuring that the highs and lows arrive at your speaker at precisely the exact same millisecond. Achieving this temporal synchronization is the fundamental key to creating a truly realistic soundstage. When these electrical pulses arrive in perfect synchronization, your brain is then able to accurately process the tiny timing differences between your ears, allowing you to hear the exact three-dimensional position of every instrument within a deep, transparent space. Preserving the signal through the cable is only half the battle. As soon as that electrical current reaches the speaker, the underlying physics completely change, and the speaker unit itself then starts to generate its own interference. It's important to understand that speakers do not simply consume power passively. When dynamic music, especially with heavy bass, impacts the cone, the rapid physical acceleration and subsequent braking action effectively functions like a generator, thereby producing a backward-flowing reverse voltage. With a single wire connection, this uncontrolled back EMF has no alternative path but to flow directly into the tweeter's circuitry, where it disrupts the precise and delicate high frequencies. To protect these high frequencies, we physically separate the signal paths using a structural solution known as bi-wiring, by running two distinct cables directly from the amplifier, one specifically for the tweeter and another for the bass. The backward-flowing bass energy is then forced to travel completely all the way down the line. The heavy block of the amplifier has an extremely low output resistance, allowing it to effortlessly absorb and dissipate the rogue voltage. Bi-wiring establishes a strict physical quarantine for the entire audio signal. This prevents the bass driver from polluting the high-frequency circuit, ensuring voices remain exceptionally clear and the bass stays firmly under strict control, even during explosive musical passages. Even with the most perfect cable geometry and completely isolated circuits, the underlying metallic material itself inherently harbors invisible flaws. The rigorous industrial process of drawing and shaping of copper wire violently stresses and deforms the metal, leaving behind microscopic fractures and chaotic atomic misalignments deep within the very internal structure of these conductors. To address structural defects, we utilize a cryogenic treatment process, carefully lowering the cables and their connectors to extremely low temperatures, specifically minus 180 degrees Celsius. When temperatures plummet to these sub-zero extremes, the immense internal stress within the metal lattice structure completely collapses. The individual molecules then bind very tightly together, instantly snapping into a smooth, perfectly permanent alignment. By permanently realigning the molecular lattice, we effectively remove the internal obstacles that cause signal loss and unwanted distortion. This process ensures that the metal structure no longer fights against the very music it was originally meant to carry. However, there is still one final and completely invisible force that continues degrading the audio quality right at the finish line. As a speaker cone is continuously pumping back and forth, this constant mechanical movement generates a cloud of electrostatic charge directly upon the isolated metal basket. In order to effectively exhaust all of this parasitic energy, engineers must implement a specialized three-pole mass return or a dedicated grounding cable system. By connecting this third dedicated wire directly to the speaker chassis, it acts much like an open valve, actively vacuuming away any built-up static charge and rogue high-frequency interference well before it can ever begin to affect the driver's physical movement. Allowing that static a place to escape results in an immediate, reproducible leap in spatial detail and tightens the mechanical control of the speaker. Single-core geometry, bi-wiring isolation, cryogenic alignment, and electrostatic grounding. These techniques do not operate by adding any warmth or color to the audio output. Instead, they work together as a coordinated defense mechanism against the fundamental laws of electromagnetic physics. Achieving high fidelity is, at its core, a process of careful subtraction. It involves the deliberate and precise removal of all those invisible physical barriers that stand between the amplifier and the air. Once you successfully eliminate all that mechanical noise, you are then left with what feels like an entirely black canvas. The playback equipment itself simply vanishes, leaving absolutely nothing behind but the artist's pure original intent. Ultimately, all the theoretical knowledge and engineering prowess in the world must yield to one fundamental, empirical principle of audio. If it sounds better, it is better.